In the last section of chapter 5, we are now going to talk about systems of linear inequalities. So, what are we going to learn? You're going to learn these 4 things. And there they are. Basically, it's like what we've just done. You are now, instead of just graphing one inequality, you're going to be graphing 2 or more, and then figure out where their overlapping graphs are, or the overlapping regions are. So a system of linear inequalities is a set of 2 or more linear inequalities in the same variables. An example is shown below. So if you would solve this, you would graph the first one and shade. Graph the second one and shade. Your solution would be the overlapping shading regions. Now, a solution of a system of linear inequalities in 2 variables is an ordered pair that would make both inequality true. So if we start with the example 1, which is super duper easy, you want to tell whether each ordered pair is a solution of the system. So you just plug them in. So if we plug in the first one, 5 is less than or equal to 6. That is true. And the second one is 5 is greater than or equal to, let's see, 3 plus 1, which is 4. That is also true. So the first one is a solution. The second one, let's plug in 0 is less than negative 4. That is not true. So this B is not a solution. All right, so now we're going to graph the system of linear inequalities. So graphing it, as we just explained, you're going to graph each inequality in the same coordinate plane. You are going to find the intersection of half planes that are solutions of the inequality. So here, this graph, we've graphed 2 separate inequalities. One of them has been shaded in a red region, and the other has been blue. This overlapping reddish blue purpley region is your solution to the inequalities. So in example 2, we're going to graph the system of linear inequalities. So by looking at this, you're going to graph the first one, y equals 3. So the boundary line would be a solid line, horizontal through 3 on the y-axis. This would be a dashed line that I would just use slope-intercept form to graph. And if you graph both, this is what it's going to look like. And here it is. There it is. Solid line showing y is less than or equal to 3. We shade everything below in blue. The second one is the dashed line in red, shaded upward. This region right here, the solution is the purple shaded region. Now, example 3. Graph the solution. Graph the system of linear inequalities. So here's the first inequality. 2x plus y is less than negative 1. I would graph that by using intercepts. And inequality 1 is right here. 2x plus y is less than negative 1. You could have graphed it using slope y-intercept. That is perfectly fine. Now, the second one is the red dashed line. Notice that their boundary lines are graphed and they're dashed because the points on these lines are not solutions. So, as you can see, they've been graphed. Now, where is the overlapping region? There is none. Therefore, this system of linear inequalities has no solution. Now, the next example, they're going to give you the graph, and they want you to write the system. So write the system of linear inequalities represented by the graph. So let's take the first horizontal line here. Well, that's easy. It's going to be the boundary line is y equals negative 2. Because it is a solid line, it's going to be is equal to, and it's shaded upward. Because it's shaded upward, it's going to be y is greater than or equal to negative 2. Now the second line, I would look at this and go, okay, It crosses through 0 on the y-axis, therefore my y-intercept is 0. My slope goes up 1 over 1, up 1 over 1, so my slope is 1. So I know it would normally be y equals x. But it's a dashed line, so there's going to be no equal to. And it's shaded below. Because you're shading below the dashed line, it's going to be less than. And that is my system. Y is greater than or equal to -2, and y is less than x. Now, try this one on your own. Example 5. Write the system based on this. So do this one on your own. Pause the video. Do this yourself. All right, the vertical line is going to be x equals 3. Since it's solid and we shade to the left, it's going to be less than. So it's going to be x is less than or equal to 3. The other one goes through -1. It has a slope of 2/3. So it's going to be 2/3 x minus 1. We shade upward, so it's going to be greater than. It's not equal to since it's a dashed line. And the last example. You have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. How much time can you spend at each location? So we have to first write our inequality. So it says we have at most 8 hours to spend at the mall and the beach. So let's say x is the number of mall hours and y represents the number of beach hours. So that means x plus y, we want to spend at most, which means less than or equal to 8. We want to spend at least 2 hours at the mall. At least 2 hours at the mall would be x is greater than or equal to 2. And we want to spend more than 4 hours at the beach. So y is greater than 4. We have 3 inequalities. Let's graph all 3. There we go. So y is the number of hours at the beach. X is the number of hours at the mall. You'll notice that none of the arrows go into the negative regions. Everything has been graphed. And this little region right here are the solutions of what you can spend where. So, if I want to know how much time you could spend, just make it up. Just tell me how much you want to spend. So we look at the shaded region. So I'm going to say right here. So that is 2.5, 5. So I could say 2.5 hours at the mall and 5 hours at the beach. That is one possible answer.